All right, let's jump straight into this explainer. Right now, literally every major enterprise is pouring billions into AI. I mean, it's the gold rush of our era, right? But there's this massive shift happening behind the scenes in how that value is actually measured and realized. Today, we're diving into tokenomics, the unit economics of the AI factory. We're going to look at how a large multinational bank can apply strict mathematical discipline to their next massive AI infrastructure investment. Because let's be real, this isn't about chasing the latest shiny object anymore. It's about cutting through all that overwhelming hype and focusing purely on the math that drives profitability and sustainable scale. So, what actually controls AI factory economics? Think about it. When you sit down to map out $1 billion build, it's supernatural to assume that those incredibly expensive GPUs dictate the overall cost. They're the stars of the show. But here is the critical insight, and this is huge. It's actually the data substrate feeding those GPUs that makes or breaks the budget. It's kind of like having a high-performance sports car. You can have the absolute most powerful engine in the world, but if your fuel pump can't deliver gas fast enough, well, you aren't winning any races. If your storage can't keep up, those incredibly expensive chips just sit there idle, and your entire economic model collapses way before you ever reach production scale. And because of that hidden bottleneck, the old metrics, they're completely dead. We are moving entirely away from that familiar cost per core measurement, and we're shifting to cost per autonomous workflow. You might be wondering, why the sudden shift? Well, it's because complex agentic AI, the kind of AI that can autonomously use tools, write code, and recursively problem solve without us stepping in, that consumes 50 to 100 times more tokens than the simple chatbots we were all playing with last year. They run in these constant iterative loops. If enterprises don't adapt their infrastructure for this massive exponential jump in data hunger, they're going to hit a scaling wall going 100 miles an hour. Success today is entirely about calculating the total compute spend required to pull off those complex, multi-step tasks. To really wrap our heads around this bottleneck, we have to look closely at the storage architecture itself. Generic enterprise storage was designed for transactional IOPS and files. And hey, it's fantastic for traditional IT workloads, databases, and file shares. But an AI data substrate, totally different beast. It is built from the ground up for one very specific purpose: sustained line rate GPU saturation. When you try to retrofit that old traditional storage for modern AI, it literally stalls the data path during sustained multi-week training runs. It simply cannot push the data fast enough. So you end up starving your GPUs, creating this agonizing long-tail latency that just completely wrecks your efficiency and skyrockets your power bills. The stark reality of this bottleneck is super obvious when you look at the utilization rates. Generic enterprise storage actually caps your B200 or H100 GPU utilization at roughly 60 to 70%. Just pause and think about the magnitude of that for a second. Generic storage leaves your multi-million-dollar GPU fleet sitting completely idle about 30% of the time. You are powering and cooling chips that are literally just sitting there waiting for data. But when you flip to a specialized solution, a tokenomics at the edge substrate, utilization rockets past 90%. You're using the exact same hardware footprint, the exact same power envelope, but you're unlocking vastly more computational power. So, to fix this broken paradigm, forward-thinking enterprises are moving to tokenomics at the edge, the substrate solution powered by DDN. This is a highly specialized parallel file system architecture built specifically to keep GPUs fed at absolute line rate. It removes the data traffic jam entirely. It's actually the exact same data layer embedded natively in NVIDIA's reference architectures, and it's the hidden engine used in those world-class massive-scale deployments, like the 200,000 GPU XAI Colossus cluster. Implementing this genuinely changes the entire foundation of the AI factory. When you fully saturate the compute layer with this architecture, the impact on your operational efficiency is absolutely staggering. We are talking about achieving 3 to 10 times more useful inference output per kilowatt compared to peer storage sets. It completely redefines the megawatt envelope of your data center build. I mean, when power is the ultimate limiting factor for AI expansion globally right now, getting up to 10 times the useful answers for the exact same power footprint, that's an absolute game changer. It takes a massive cost center and transforms it into a hyper-efficient asset for any CFO. And beyond just power savings, there is a massive advantage in speed. For customer-facing latency budgets, think about real-time fraud detection at a major bank or algorithmic trading where literally every millisecond matters. Fixing the data substrate drives a 40% reduction in time to first token. Your AI doesn't just run cheaper, it responds significantly faster because the data path isn't stalling out mid-thought. This directly elevates the end-user experience, turning those clunky, delayed interactions into seamless, instantaneous intelligence. Okay, let's step out of the data center for a moment and look at the realities of procurement, because this is where things get incredibly practical. Normally, ordering these high-end NVIDIA GPUs leaves you stuck in a massive global queue, right? You're waiting 36 to 52 weeks just for delivery across North America. The hardware is just that constrained. However, through a bundled order channel tied directly to this DDN substrate solution, hardware delivery is secured in just 8 to 14 weeks. You circumvent the typical year-long wait entirely, which means your AI strategy actually deploys and starts generating revenue on schedule rather than just languishing as an idea on a whiteboard. So, what does all this efficiency and speed actually mean for the bottom line? Let's use a large multinational bank as an example. Avoiding the need to overorder GPUs just to compensate for idle storage time translates directly to an incredible $120 to $200 million in year 3 run rate savings. You no longer have to buy a third more GPUs than you actually need just to hit your throughput targets. That isn't just an IT saving. That's a massive boardroom-level metric that fundamentally reshapes the entire enterprise infrastructure budget. Which brings us to the financial inversion, and specifically, the verified outcome model. Because amazing technology isn't enough on its own to guarantee success at this scale. This new infrastructure enables a completely different operational approach. In the past, companies simply bought hardware and basically hoped for the best. Here, instead of the bank bearing the brunt of the execution and capital risk, that massive burden is placed squarely on the operating partner. Here is how this financial inversion actually works in practice. Instead of paying a partner for mere effort or racking up endless hourly consulting rates with absolutely no guarantee of success, the partner actually deploys their capital first. They only recover their costs based on independently certified quarterly outcomes against an irrevocable, locked baseline that's established on day 21 of the engagement. With an independent third-party audit panel verifying the results and a dedicated 9-person strike team managing the operations, it becomes a true gain-share model. Everyone has real skin in the game.
The big takeaway here is that this is a total paradigm shift in how we procure and deploy AI. You're moving away from a risky, time and materials money pit where the client bears all the capital risk, hopes the integration works, and waits a whole year for hardware to arrive. Instead, by leveraging tokenomics at the edge, you get an audited, performance-guaranteed AI factory. You're hitting 90% plus GPU utilization, you're sharing that massive capital risk with your partner, and you get your hardware fully operational in a fraction of the time. It's a complete 180.
And that naturally leads us into locking the baseline and navigating the 12 to 18-month decision window. The data shows a very strict window here. Right now, every single major enterprise is reevaluating their AI data substrate, because they're realizing just how inefficient their current setups are. The opportunity to outmaneuver your peers, lock in these superior unit economics, and secure a highly defensible cost position for the next decade, that opportunity is right now. But within 18 months, this architecture simply becomes industry table stakes, and that early mover competitive advantage will be gone forever. And the market already recognizes this rapid shift. Top financial CEOs are actively pointing out that capital has priced the inversion. The broader markets are already valuing outcome-based AI services infinitely higher than traditional, effort-based hourly models. Billions of dollars are currently flowing into AI-native services built entirely on forward-deployed engineering and outcome-based billing. The smartest money in the room is already waking up to this exact reality, recognizing that the old ways of building infrastructure just cannot support the AI factories of tomorrow. So, here's the most critical question we're left with. Will you lock your baseline before the window closes? The clear next step is to schedule a 60-minute discovery session to measure your own tokens per watt today. Because as the landscape inevitably shifts from basic cost per core to the much more demanding cost per autonomous workflow, you really only have one choice to make. Do you want to ride the front of this massive wave or get crushed by it? Thank you so much for joining me for this explainer. I really hope it gave you a crystal clear view of the math driving the future of the AI factory.